have spent months building your application. It is deployed, people are using it, until one morning somebody has stolen your whole database. All of your users and passwords now belong to somebody else. Not only they can look into your system, you also breach the trust of all of your users. And the saddest part is that it's so easily preventable. In this video, we're going to go over a few pretty simple concepts that will make your app more secure. And even if you do get hacked, at least you know that you didn't leave the front door wide open. I am by no means an expert in security. It's actually the opposite. In every place where I worked, I had a team of security experts that were always ready to come and help and rescue us. But not everybody has this luxury. In the first part of this video, we're going to cover everything that comes from the user input. And in the second part of this video, we're going to look inside your software. Check the description down below for a checklist of things that you want to go through for your app. And don't forget to leave a comment if I missed something. Why are we talking about user input? Because we don't trust the users. Some healthy level of paranoia is crucial for good development. So the first principle or concept that we're going to look at is zero trust. Every user is a potential security threat. And if we don't trust our users, we want to restrict the amount of things they can do with our application as much as possible. A small disclaimer, I am a backend engineer, so I'm mostly talking about the backend perspective. Of course, there are multiple things on the front-end side that can also go wrong, but unfortunately, I'm not an expert in that area. Remember that the backend is the last line of defense, which means that we have to make it very secure, but it also means that it would be nice if front-end catches some of it before the data is even sent to the server. How do we restrict what a user can do with an app? If we're talking about backend, there is an entry point. It's an API call that the user is making either directly or through the front end or maybe through a mobile app. And one thing that you can always do for your users is to make the contract as strict as possible. You want to restrict which data can possibly be sent to your endpoint. For example, you have a list of fields, and if you expect a numeric field, do not accept it as a string. And that leads us to the second principle, which is data validation. Once your request is serialized to an object or structure that you expected, you can run your own validations. You don't necessarily have to write it yourself. There are multiple libraries in multiple languages that do that. Make sure to specify what is the minimum and maximum value. What are the allowed characters? If you only allow a list of specified variables like red, yellow, and green, just reject all of the other parameters. The main thing to remember here is always whitelist and not blacklist. If you're writing all the characters that are allowed, and you forget something, you're going to have a couple of annoyed users who cannot use perfectly legitimate characters. But if you block some characters that you deem dangerous, you can miss something, and then let's say a lot of people will be complaining instead. Another important thing about data validation, never give too much feedback. I think it's perfectly okay to tell the users which characters you are expecting. Don't provide too much details, because if you're leaking technical information and how your validations are working, somebody can just find a way around them. Pay attention to all the strings or free text fields that you're accepting. They are the most dangerous because they give the user the most freedom, but they are almost never avoidable. For example, if you're running a service that lets users add a book, the users will add a title and a description, which are all strings. If you have a search endpoint in your system, chances are it uses query parameters, which are also strings. Strings can contain SQL injections, they can contain executable scripts, and it's very easy to forget that strings are not just the text that user can send, but they also be contained in a file. So what can you do? We can check the type of the file that we receive. Don't always trust it, it can always be manipulated with, but it's something worth checking. And if it's a file that can be sanitized, there might be a wise thing to do, but please don't go through the files searching for the script tag on your own. There are multiple libraries that do that, that were tested multiple times. And the most important thing about files, if you're receiving files, chances are you're going to store them. Make a list of the file extensions that you allow, and never save a file with a different extension. For example, if you're saving a meme, it's probably gonna have an image extension and not some executable file one. So check the type, sanitize, and reject any extension that you don't like. Going through all of the rules and not trusting the user may sound a bit over the top, but the good thing is that it will not only help you with the security of your app, but it will also protect your app from honest mistakes that users are making while using it. Now let's take a look at the implementation of your app. And the first thing we're going to take a look at is authentication and authorization. I don't know who had this genius idea to use two terms that are so close to each other but so different. But it keeps confusing people, and these are actually the things we really want to keep apart. Authentication is telling you who the user is, while authorization means that the user has rights to perform different roles. And those distinctions are very important because in the beginning you may think that they are almost the same. If the user is an actual registered user and he can log in with his login and password, then he can access the app data. But as your app evolves, you have more users, you have more roles. You have an admin that can do way more than a regular user, while the authentication may stay the same as it was in the beginning. First of all, the majority of the software nowadays is using OpenID, which you've seen multiple times when you go to some website and it tells you that you can log in with your Google account or Apple account. And that is making it way easier for you because you don't have to store passwords. But for our little beginner app, sometimes it is normal that you want to store user login and a password in your database, maybe as a temporary step, or you just want to provide another opportunity for people who don't want to use OpenID. And you know what I'm going to say, and I'm still going to say it, never ever ever store passwords in plain text. You may say that nobody's storing passwords in plain text, but there is a reason I'm making this video. If you don't know how to store passwords, then look up hash functions. A function that takes some information, password in our case, and transforms it into, for example, a random string. You will never be able to get what was the string created from, so you will never be able to guess a password. But if you provide absolutely exact string, it will provide absolutely exact hash that you can store. And then when the user tries to log in, instead of comparing plain text with plain text, you're converting what the user gave you into a hash function and comparing it to the hash function in the database. And you get the points for not using user input directly. I know it can be very tempting to have a database table called users that will have login, password, and a role. Not a good idea. So try to store them separately from the very beginning. And also never reveal the roles that your system has to your regular user. Use your judgment, but a good rule of thumb would be to imagine that you're a spy in the movie and you're trying to reveal as little information as possible. One of the most vulnerable places in your system are SQL queries. Chances are you will have to accept some of the user input directly into your query, for example, a search term. So make sure you're taking all the necessary precautions, you're sanitizing the data, you're trying to escape the characters, you're using prepared statements or parameterized queries. Basically, search how to avoid SQL injections in your given language and then just use a library or a solution that is provided. I have to say SQL injections are a bit less common in my line of work because we're rarely writing raw SQL queries, but in your beginner app, pay attention to that. And my last point is probably one of the most important points. When your app is running on your local computer, you can always debug, you can stop it, you can rerun it, you have access to all of the data, and you feel very confident about how it behaves. Once your app is deployed, you're basically blind. You only see the log statements that you included beforehand. You sometimes don't have access to your user data. Your app lives somewhere without your active supervision, and anything can go wrong there. Your task is to make sure that if something goes wrong, you know about it. So the first thing you can do is, of course, log all the errors, all the exceptions, all the unsuccessful attempts, all the data validations. So if somebody provides the information that is wrong, you will know about it. So if somebody tries to provide malicious data through different ways, you will know about it by looking at the logs. Almost nobody hacks a website manually nowadays. They're using specialized software. So maybe if you're receiving hundreds of rejected parameters per second, it's wise to sound an alarm so you are alerted and you can look to your logs and figure out what's going on. Of course, it might also be nice to have some kind of safety feature or a kill switch that will help you stop this attack, but I don't think this is the beginner level conversation. And whatever you do, don't hard code your API keys, don't store your tokens, and do not have debug mode in production. And if you're using a cloud provider for your app, don't forget to set up your budget alerts and limitations, just in case all of the measures you've taken were not enough. I wish you all the luck with your application, and I really hope that none of the measures we talked about will be actually tested in real life. And I'll see you in the next video.